in the implementation, we immediately got two really good ideas, okay? One is, look. Find the initial velocity from the projectile behavior. I'll just say from the projectile information, right? The other is find the initial velocity from the energy conservation with the rubber band, right? If the force is completely conservative, then the energy it took to pull it back is going to be the same as the energy released into the rubber band when you let it go, which means its velocity at this point will be known. Now we do know that it loses energy out of contact with my finger and so forth. So, ideally we would try to minimize that in a real analysis, okay? In an analysis of a real situation. We also know the angle and direction from which it was, and altitude from which it was released, and how far it went before it fell to the floor, right? So we can analyze the projectile motion and get a velocity. Okay, so in comparing these two, we get very close to this question, don't we? And all that is pretty obvious if you list the principles, think through what's going on, and see that there are two chunks of information here. One that gives you the energy, one that gives you the projectile motion, right? And if you've done the homework and analyzed problems of this nature, either one of them is relatively straightforward to analyze, okay? That projectile motion problem is, it's got a little twist in it, but it's just a standard projectile problem. The energy analysis is straightforward, and we've done it recently, right? So I'm going to sign that. I want you to see if you can get that done before lab on Friday, okay? And Friday in lab, we're going to play with rubber bands, among other things.